Soaps and detergents. Soaps and detergents are used for washing dirty clothes. Our body secretes oil and grease which sticks to the clothes we wear. The oil or grease stains on the clothes attract dirt particles and make them dirty. It is not possible to clean these dirty clothes thoroughly with water. It is because oil and water repel each other and do not mix with each other. We take about 10 ml of water in 2 test tubes marked as A and B and add groundnut oil to both the test tubes. We next add a piece of soap to test tube A and vigorously shake both the test tubes for some time. We then keep the test tubes A and B undisturbed in a test tube stand for 5 minutes. We find that in the test tube B, groundnut oil can be seen floating over water because oil is lighter than water. We infer that oil cannot be mixed with water even on vigorous stirring. In the test tube A, we find groundnut oil drops, water and soap form a uniform solution. We are not able to see groundnut oil drops floating on the surface of the solution. So, we infer that soap helps in mixing oil and water. Soaps. Soaps are sodium and potassium salts of long-chain fatty acids with general formula RCOONA or RCOOK. The acids present have the formula RCOOH, where R may have a value. Examples are palmitic acid, oleic acid, stearic acid. These fatty acids exist as triesters of glycerol, which is a trihydric alcohol. The triesters are also called triglycerides or simply glycerides and are the constituents of edible oils and fats. These are of animal and vegetable origin, for example, castor oil, linseed oil, or soya bean oil. Chemically, the triglyceride are formed as a result of esterification reaction. The group R may be either same or different. If these are same, the glycerides are simple glycerides. In case they happen to be different, then glycerides are known to be mixed glycerides. Preparation of soap. Soap is prepared by the action of sodium hydroxide on oil or fat by the process of saponification. You can see in the animation that oil is taken in a container where it is mixed with the help of a rotator. Hot water and sodium hydroxide is added while the solution is stirred so that proper mixing is done. Sodium hydroxide reacts with fatty acids to form soap. This can be shown by the help of an equation. Oil or fat reacts with sodium hydroxide to give soap and glycerine. This process is called saponification. Brine is then added to the solution. Glycerine formed in the reaction is removed by dissolving it in brine solution. This is called as salting out. soap solution rises to the surface and is collected as soap curd. Glycerine and brine solution are removed. Soap is collected in containers and cooled. Thus, soap is a sodium salt of fatty acid. Soap does not lather easily in hard water. We all know that soaps are used for washing clothes. However, these are not effective in case of hard water. The hardness of water is due to hydrogen carbonates, chlorides, and sulfates of salts of calcium and magnesium present in hard water. Soaps are sodium salts of carboxylic acids. RCOONA, where R is a long chain of alkyl group. When soaps are added to hard water containing calcium and magnesium ions, the sodium salts present in soaps are converted to their calcium and magnesium salts, which get precipitated as scum. Froth is not formed in this case and soap simply gets wasted. Ca2+ reacts with 2RCOONA to give RCOO whole twice Ca plus 2Na plus ions. Mg2+ ions react with 2RCOONA to give RCOO whole twice Mg plus 2Na positive ion. Water from these salts is known as soft water. Soap is effective when water is soft. Let us compare the comparative capacity of a sample of soap in soft and hard water. For this, we take 3 glass test tubes in a test tube stand and label them as A, B and C. We take 10 ml of distilled water in tube A and same volume of well water or tap water, that is hard water, in tube B. In tube C, also take 10 ml of distilled water and to this add 1 gram of calcium hydrogen carbonate. Stir the contents well of tube C so that calcium hydrogen carbonate completely dissolves in water. In a glass beaker, take about 50 ml of tap water and dissolve about 5 gram of soap in it with constant stirring. Add 5 milliliter of this soap solution in all the 3 test tubes. Shake the contents of the tubes one by one by holding them in hand and covering the mouth of these test tubes with thumb. Foam or lather will appear in all tubes but not to the same extent. It will be maximum in the tube A containing soft water, lesser in tube B containing hard water, and minimum in tube C which has extra hardness. Mechanism of cleaning. Soaps and synthetic detergents are known for their cleansing action. The principle is the same as both have very similar structures. The long hydrocarbon tail is soluble in oil but insoluble in water. It is hydrophobic or water repelling. The negatively charged head is insoluble in oil, but soluble in water, which is hydrophilic or water attracting because water is a polar solvent. When soap or detergent is dissolved in water, its polar head is attracted to the water molecule. The non-polar tails are hydrophobic, so tails of several molecules join together. The non-polar tails are hydrophobic, so tails of several molecules join to form a cluster. This peculiarly arranged cluster is known as micelle. A micelle is a large number of soap molecules with their sticking inward and head outwards. The soap in detergent solution is only a colloidal solution containing several such micelles. The micelles remain suspended in water. When the dirty cloth is dipped in soap or detergent solution, the non-polar hydrocarbons tails begin to enter and dissolve the non-polar oil or grease containing the dirt, while the polar or ionic heads part dissolve and attach to water. Now that you know that soaps and detergents are substances that you come across often in everyday life, they are used for cleaning and washing. Soaps and detergents are made up of molecules with a specific structure. Two ends of these molecules show typical behavior towards water. One end of the molecule bears a negative charge and is called as polar head. So, it is polar head that interacts with the water molecule. The other end is non-polar and does not interact with water. Let us now determine which model shows the behavior of soap in water and which shows its behavior in oil, a non-polar substance. Choose the appropriate solvent name. After having a look at the first figure, which one do you think is the correct answer? Water or oil? I am sure that by now you all know that the polar parts of soap molecules interact with water but avoid contact with oil, while the non-polar parts of soap molecules interact with oil but avoid contact with water. The correct answer is yes. This behavior is shown in water. Let us now have a look at the second image. What do you think? Is this behavior shown in oil or in water? The polar parts of soap molecules interact with water but avoid contact with oil, while the non-polar parts of soap molecules interact with oil but avoid contact with water. Yes, we know now. The correct answer is that this behavior is shown in oil. Synthetic detergents. Soaps have problems when used with hard water. Hard water has calcium and magnesium which does not create lather. Synthetic detergents have overcome this problem. Synthetic detergents do not have sodium salts or fatty acids. In spite of this, the detergents have all the properties of soap. Synthetic detergents have long-chain molecules such as sodium N-dodecyl benzene sulfonate and sodium N-dodecyl sulfate. The chemical structure of these molecules is as shown on screen. We can see that the synthetic detergent molecule is similar to the soap molecule. It has a long hydrocarbon chain or tail. These two parts are water repellent and water attracting respectively. The cleansing function of a synthetic detergent molecule is similar to that of the soap. Although soaps are excellent cleansers, they do have disadvantages. As salts of weak acids, they are converted by mineral acids into free fatty acids. CH3, CH2 CO2 negative, Na positive reacts with HCl to give CH3, CH2 CO2H plus sodium ion plus chloride ion. These fatty acids are less soluble than the sodium or potassium salts and form a precipitate or soap scum. Because of this, soaps are ineffective in acidic water. Also, soaps form insoluble salts in hard water, such as water containing magnesium, calcium, or iron. 2CH3, CH2 CO2 minus Na positive reacts with Mg2 plus ions to give CH3, CH2 CO2 whole twice Mg2 positive ions plus 2 sodium positive ions. Let us have a look at how synthetic detergents are manufactured. Unlike soaps, a synthetic detergent is prepared by the reaction between oleum, alkyl benzene and sodium silicate. The mixture is then fed in a tower. Hot air is blown from the bottom of the tower. The mixture dries in the form of granules, which is then collected, screened and packed. Both soap and synthetic detergent act on the dirt particles by forming a micelle around the dirt particles. Advantages and disadvantages of synthetic detergents over soaps. Soap cannot be used in hard water. Synthetic detergents can be used in hard water. Soap is made from vegetable or edible oils. Synthetic detergents are made from byproducts of petroleum industry or petrochemicals which help to conserve valuable edible oils. Soaps cannot be used in acidic medium as this would precipitate the fatty acids. Synthetic detergents can be used in any medium, including acidic medium. Soaps have a weak cleansing action. Synthetic detergents have strong cleansing action. Soaps are not very soluble in water. Synthetic detergents are highly soluble. Soaps are biodegradable and do not cause any pollution. Some synthetic detergents are not biodegradable and cause water pollution. This, in some cases, can become quite serious. Harmful effects of detergents. Biodegradability means breaking down of large organic molecules into smaller ones by microorganisms present in sewage discharge. A comparative study of soaps and detergents reveals that detergents are better than soaps in many respects, but detergents are non-biodegradable, whereas soaps are biodegradable. The widespread use of detergents over years has resulted in the pollution of water obtained from rivers, lakes and other sources. The main reason for the non-biodegradable nature of detergents is the presence of branching in the hydrocarbon chains that are attached to the sulfonic acid group of its sodium salt. These chains break with difficulty by the microorganism present in sewage discharge, septic tanks or other water bodies. They make the detergent non-biodegradable and are responsible for pollution problem. Difference between soaps and detergents. Since the soap does not rinse out as good as detergent, it tends to build up on the clothes and over a long period of time causes the fabric to deteriorate while leaving an odor. Another shortcoming of soap is that it is less powerful than synthetic detergent and tends to lose its cleaning power over time. So don't wash your laundry with soap. An added benefit of detergents is that they can be specially engineered for each cleaning task and to be used in different types of machines. Front-loading washers produce better cleaning results when the clothes strike the wall of the washer tub as it rotates. This type of machine will clean your clothes better if there are fewer bubbles to cushion their impact. Top-loading washers, on the other hand, function better with more bubbles since the bubbles trap excess dirt and keep it from reattaching to your clothes. Many people also have a fascination with the spectacular colors produced by bubbles. Little do they realize that bubbles are an important aspect of the detergent's cleaning action.